The pseudocode has two main parts, the main program and the other one is called functions. Now, main program is what we were dealing with, right? Where we were defining all the pseudocodes. Now, pseudocode in the main program can call functions. And then function will get executed. So main program, it will call function. And then the function will return. So there is a call associated to the function. And then there is a return associated back to the main program. So that is how the communication between function and the main program works. Main program calls and function does a particular task. And then once that task is done, it returns whatever is being asked to return. Number one. Now, for example, if I have a main program where I say input A, comma B, I am taking two variables A and B. And then I say sum is assigned 0. So I declare another variable called sum and I assign the value 0 to sum. Now I want to add these two functions, these two numbers A and B. So rather than simply saying sum equals to A plus B, as in sum equals to A, that is one way of doing it, and I say print sum. That is one way of doing it. You enter A, you enter B, you define sum equals to 0, and whatever A and B have been inputted by the user, the addition of those two numbers are stored in that variable sum, and the sum is printed. Great, right? This is the main program. Not a problem. Now there's a function implementation of this where I say input A comma B, and I say sum is 0. And now I say sum equals to addition A comma B. And my program, and I say print sum. Now, the computer control comes here. It takes the value of value A, and let's say users inputted 3. Then it takes the value B, and let's say users inputted 2. Now, once that is done, a sum variable is assigned with value 0 in it. Now, when control comes here, it says sum equals to, computer says, okay, I now see something called addition, which is not a standard command for me. This is a function, which is accepting two inputs, these two numbers. So computer starts to search where in the memory, where exactly this addition program or this addition function is being written. So you need to define the function. So what we'll say is, so you then have to define a function. We'll say define addition. Let's say n1 comma n2. And then you say S equals to, so you define, then you say S is 0. And I say S equals to N1 plus N2. And then you say return S. Now let's see what happens. So your computer, your control of your computer was here at sum. It says, okay, I need to find a function with the name addition. And I have to call this function with two values a and b. In this case, a and b is 3 and 2. So this computer program will now call addition with two values 3, 2. So computer, rather than going to the next statement, passes its control to the function itself, where it's found the function definition. Now what happens here? The name matches. The computer now know, okay, this is where I need to go. And since this addition is passing two numbers, your function definition have to accept these two numbers in two different variables, n1 and n2. So this is now 3 and 2. So what happens is that these a are also the same values as n1 and n2. So n1 and n2 are basically pointing to the same location, which is a and b in the memory with the value 3 and 2. So now n1 and n2 becomes a and b for this program, for this function addition, a synonym. So the control goes inside and they said, hang on, I need to declare another variable called s. So this was sum. So it declares another variable s. Goes to the next command and it says, okay, what do I need to do? S is basically, I'll just use the pseudocode definition. Rather than equal to, I'll use an arrow. S is n1 plus n2. What is n1? 3 and 2, which is nothing but n1 and n2 are 3 and 2, which is the original a and b. Add them. So this becomes 6. And then it says, okay, I have to go back now where I came from. But I have to carry S back. What is S? 6. It goes back up with 6. Therefore, when it returns back, this call that you have made to the function at the first place has returned a value 6, which is now, it is equal to, so 6 is being stored in the sum. So now sum becomes 6. And finally, you'll say print sum. So on the screen, you'll see 6 being printed. So that is how a function is being called from the main program. So this is the main program, and this is the associated function in the main program. So whenever from the main program your function is being called, the control of the computer program will shift to that function and will go back to the main program after the return is given. And you go back up. And then it resumes its journey. Now you could argue here, I mean, this was easy, right? Why we have complicated our lives, right? You can argue that. But what if I have to now add 5 different pairs of numbers? So one way is I repeat this whole block 5 times, or I just call this definition 5 times, which essentially means I can write it like this and say, okay, input a comma b, sum is 0, sum equals to addition a comma b. And I say print sum. Let's say I want to again add two numbers. So I can accept the two numbers again and say input c comma d. And rather than writing sum equals to a plus b, I simply say sum equals to addition c comma d. So every time you call this function, this block of statements are repeated by just one word, by using one word. So you've just defined these 1, 2, 3, 4, 4 statements once, and you can keep calling them any number of times in your main program. So that is where, when you need a specific task to be done multiple times, rather than making it part of your main program and just repeating those statements again and again, you simply define it as a function and just keep calling it every time you want. Is this clear? Right?